equals x squared minus 1. How do I switch the x and y's, Cayman, if there is no y?
And you could say that y equals f of x, so you can say y equals x squared minus 1.
Good. And so now this is the original function, and we've written it now with a y in place of the function notation f of x. Because what is this saying? This is saying the value of the function for a given x value is defined by or equal to take the x value and square it, then subtract 1. And for every different x value, you're going to get a different function value. And what you can do is say, well then for that x value, I'm going to graph the function value, and I'm just going to then call it y, because that's how we graph on a coordinate graphing system. You have a corresponding value for every x value, and we're going to say, yeah, let's just let that be y, and now we're dealing with the coordinate graph system of x and y points, okay? Now, if we want the inverse, what do we do, Henry?
We just switch the x and y.
We switch wherever you see x, write y, and wherever you see y, write x. And now, Hannah, what do we have to do?
Put a square root.
Okay, but before we do that, we're gonna do what?
Have one both sides.
Add 1. So we're going to solve for y by adding 1 to both sides and then taking the square root of both sides. And Mr. Thomason's not here for me to pick on him. What do we do when we take the square root?
You plus or minus.
You do plus or minus the square root of x plus 1. Now, if I want to find the inverse of f of x, I can't end with y equals, because I don't have any indication that this is the inverse of my original function. So Leah, I need to substitute for y. Now remember, y is now a different y, if you will, because we solved for y and then we swapped the x's and y's. So now, if I were to do it maybe with colors, these two are equivalent, just written with different. This is in function notation, this is in coordinate pair notation. Now when I switch the x and y's, this one is a new and different function. It's not the same. So this y equals is not the same as this y equals. So we really can't leave it this way, or else it's going to be both confusing and imprecise. So we need to say that it's equal to something other than y. Who did I call it? Leah. And so what am I going to write?
F to the negative 1 power x.
Okay, and then the one thing to say is we don't want to think that this is an exponent, because when we write the inverse function of x, we do not mean that it's 1 over f of x. This is not an exponent, right? And your book made that clear. It's not this. This is now just a way of notating the inverse function of x. And let me just look in the book to see how we want to read that. We're going to read it, look at the bottom of page 606, right above the yellow caution box. And you would have done this for homework if you read the section, which you should always be doing. And it says, read, and then if you weren't sure how to say it, you'd have been like f to the negative 1. But they're telling you how to read that. You're going to read it as, quote, the inverse of f, or you can just say f inverse. So you can say f inverse of x, f inverse of x, or you can say the inverse of f of x. And then you'll hear me say the inverse function of x is the third way to say it. Okay? All right, so we know how to do that. We know how to find the inverses. We know how to tell whether you're even going to have a one-to-one function or not. Now, we want to talk about graphing it, graphing them. Please tell me I brought my computer. Where's my bag with my computer? Excuse me. I brought the other computer. All right, so we want to look at some functions today and then try to take their inverses. So Miss Claxton, will you go to the board, please? You want to plug me in down there, Brody? Actually, you know what? Is there? No, there's not one here, is there? There's one behind Amanda. Can you hand that under the table to her? Yeah. Hold on a second. There we go. All right, so we're going to go to Desmos. That's not a calculator. All right, you want to turn some lights off? Maybe just this one. Yep, that's perfect. All right, and I'll try to sit down camera so you can see better. All right, so Miss Claxton, I'm going to put a function up here. I'm just going to make one up. Let's actually use our x squared minus 1 function. What do you expect it to look like, Rebecca? X squared minus 1. A parabola.
That is, okay. That will move it over, correct?
You tell me.
Getting mixed up. Lost everything. I don't remember. It'll move it in a certain direction.
It'll move it in a certain direction. Hannah, if I take, for every x value that I otherwise would have had y equals x squared and just squared it, I'm now going to, whatever I get, I'm now going to subtract 1. What does that do to my graph?
Move it down.
Moves it down 1. So go ahead, Rebecca, and take a marker and write what you think the parabola x squared minus 1 is going to look like.
Trying to think. I cannot remember it all.
Okay, so let's plot some points. If x is 0, y is going to be
Negative.
good. If x is 1, y is going to be, if x is negative 1, y is going to
Ah,
be,
that's what
if x is 2, y is going to be
I thought. This is 2, 3.
3, because 2 squared is 4, minus 1 is 3, and do you think you're going to do minus 2? 3 squared is 9, minus 1 is 8, so you're going to go all the way up to 8 for the next one, and so on. And on the other side, all right, so let's see if she did it. Let's see how she did it. You ready? How'd she do? She did quite well. Now, Miss Claxton, is this a function?
Yes.
Is it a one-to-one function?
No.
How do you know?
Or lines.
So, what if you took your eraser and erased half of your parabola, not that half, the left half of your parabola, and only started, so you restricted your domain, Amanda. You said, I'm only going to let x equal from 0 to infinity. I'm going to have a function that's defined by x squared minus 1, but only for x's from 0 to infinity. So now do you have a one-to-one function? The black one is what you're looking at.
Mm-hmm.
You do. You've got a one-to-one function. And if so, if you restrict your x values to 0 or bigger, we're good to go. So now what we're going to do is I'm going to hide this one. We'll bring it back later. I'll take a different color. And we're going to find the inverse of this function, Leah. To find the inverse of the function, for every point, what do we do? Very good. So for x equals 0, can we make a little chart maybe, Rebecca, off on the right there? You did the point 0, x equals 0, y equals negative 1. And then you did the point x equals 1, y equals 0, and then you did the point x equals 2. Yeah, you did that one, but we're not allowing it right now. And then you did x equals 2, y equals 3. And let's go ahead and do x equals 3, y equals 8. Okay? Now let's do the inverse function. So now write a new chart with x, and instead of y, let's write inverse function of x, or f inverse of x. Okay, so now we got to swap them all. So go ahead and do that. So you see what she's doing, everyone? She's just reversing the x and y values for every point. Now graph those. By the way, Henry, for that black one, we said the domain was going to be restricted to x greater than or equal to 0. What is the range for that original one?
The original?
Black one, yep.
Including -1 to +infinity.
Good. So can you jump up and over on this left board, can you write the domain and range of that original black function? This is for the original one. Now, while he's doing that, Cayman, you see the blue one that Rebecca did?
Yes.
What's the domain of the blue one?
It would be including -1 to +infinity.
Good. And what would the range be? It's perfect. What would the range be? Excuse me?
Because the point 0, never mind.
You just could have gotten up a little bit. You make your point, you make a big point, and we'll say it's close enough. Look, it goes right through that point. But that's all it was. You could go a little bit higher, faster, that's all. But other than that, it's perfect. So, Cayman, I didn't hear what you said from,
And the range would be.
I didn't hear for domain, can you repeat it?
Oh, sorry. It would be a bracket including -1 to +infinity.
Okay, so Henry, can you write that now, maybe with blue marker? Toss it to him if you need it. You got it? All right, so now Cayman says the domain for the blue one is going to be from negative, what did you say?
-1, including -1 to +infinity.
That's the domain.
That's what he
Did I
said.
do this one wrong?
We'll find out.
Okay.
And the range, Cayman?
All real numbers.
Really?
Wait,
So
wait.
look at the blue line. Does on the left side, is there an arrow?
On at which part?
On the left side of the blue graph.
No.
So it doesn't keep going. She has a point there, right? So it's not going on forever. It stops right there. So will it ever be negative?
At negative or no.
So the x's can be negative for a little while at least, but the y's will never be negative. So what's the range?
So it'd be 0 to +infinity.
Including
You want to include 0?
Yeah.
Okay. Now, Mr. Trice, back away and look at your black line again. You wrote something different than you told me originally.
Yeah, I just switched the domain.
What's the domain of the black one? What are the x values for the black one?
The x values, there's 0 to infinity.
Good, so fix that one for your domain. And you told me correctly when you did it originally.
That's right.
Okay, and then look at the black one. What's the range of the black one?
Range of the black one is going to be -1 to +infinity.
Good. And you're going to include -1. All right, good job. So have a seat, Mr. Trice. So, Ms. Blackson, you've correctly drawn them, and we've now given the domain and range. Mr. Ecton, what do you notice about the domain and range of these two?
They're exactly opposite.
Yes. So the domain of the black one is now the range of the blue one. And the range of the black one is now the domain of the blue one. And so in a sense, we swapped all the x and y values. Does it make sense that we're now swapping domain and range? I think that makes sense. All right, thank you, Ms. Claxton. Have a seat, Mr. Ecton. Are you able to get out? Here. Oh, no. I was not wanting to move this. All right, let me put it back. Ah, man, it's all messed up. All right, we got to fix this, Mr. Ecton. How are we going to make this right? Ah, is that close enough?
I think it's
Oh, it's over. It's over one. Oh, man. What just happened?
Why don't we just erase it?
No, don't erase it. What just happened? I think I knocked the cord out of the computer. Come on now. You got input? There it goes. All right, so we need to move it this way. And teach me to just move. Is that good enough?
Yeah.
All right. All right, now what we're going to do is we're going to put in a new function. Miss Lindsay can help us out here. What we're going to do now is, I don't know, let's try to do, well, we're doing exponential equations in this chapter. Let's try one. So to be an exponential equation, I mean, it's an equation with an exponent, right?
No, it's when the variable is raised. No, when the variable is the exponent.
Okay, so when there is a variable in the exponent, okay? So we need a base, Miss Lindsay. We need a number to be the base, and then we're going to raise that base to a power that has a variable in it. So give me the 3. And we're going to raise that to a power that has a variable in it. We could just raise it to the power of x, but that would be way too easy. So let's do something like x squared plus, we'll do 1. All right? I should have hidden it before I did. All right. All right. So, Mr. Ecton, can you use red for us if you're not already there? Let's make a chart. How about on the left side there? In the right there, yeah. Let's do x and f of x. And let's just throw some numbers in, okay? So, can we let x equal 0?
Yes,
What do we get? We get 3 to the first power.
that's an exponent,
You're right, that's right. So now we've got an exponent that is itself has an exponent. So we're doing 0 squared is 0, plus 1 is 1, and we end up with 3 to the first power. So when x is 0,
right? Just 3.
we just get 3. So right, when x is 0, write 0 for x, and then f of x is going to be,
This is 3 plus 1. 4.
no, we're taking 0 and squaring it,
Which will be 0
plus 1,
plus 1.
so now we have 3 to the first power.
Oh, you're adding an exponent. I didn't see that. Okay.
How's that?
Yes.
Is that clear? Is that clear?
we just need
That whole parenthesis is the exponent. All right, let's let x equal 1.
1,
So we get 1 squared plus 1 is 2, 3 squared is 9. Very good. Let's let x equal 2. 2 squared is 4, plus 1 is 5. 3 to the 5th power is 81 times 3, 243. All right, now, what happens, Cameron, if I let, am I allowed to let x equal minus 1?
yes.
So if x is minus 1, Brogan, so go ahead and put minus 1. I get minus 1 squared is
1
plus 1.
plus 2.
So 3 squared is,
9.
yeah, okay.
Yes.
And you could do minus 2, sure. Oh, we'll slow down here. So what's minus 2 squared?
4.
Plus 1?
5.
Good, so it is the same. All right, so let's graph these things. You're going to have a hard time finding 243 on our graph, but good luck. All right, so 0, 3 works. 1, 9.
2. Somewhere up there.
It's way up there. You can't do that. But when you go from x equals 1 to x equals 2, you need to go very steeply.
Yes. So here.
All right, let's see how I did. Did all right? All right. All right. Very good. Now, is that a function, Mr. Ecton?
Yes.
Is it a one-to-one function? It's not, is it? So can we limit our x values and make it a one-to-one function?
Yes.
What can we say?
We can just cut it off at 0.
Good. So, Brogan, Cayman, will you go over where Henry did and with a red marker? We're going to limit the domain, same as we did before, from 0 to infinity. Okay? So misdirected, I'm gonna get rid of this. And now I want you to pick another color. How about pick black? So go ahead and write in red the domain and range of Brogan's function.
Okay. The original one?
Right.
Okay.
And now Brogan, we're gonna do a new one with x. So make a new chart with x and f inverse of x. Okay, and how are you going to do that? What do you do to get the inverse of
The
it?
same way we did it there, except for inverse. That's what
So go ahead and do it. Now remember though, we're not letting x be, in the original function, anything negative. We're going to go from 0 up. So that's not what you told me. Okay, so we're going to limit it, came into 0 to infinity.
Oh, okay. So the original. Okay. So it would be for the domain.
Right. We're going to limit it so that it's a 1-to-1. Alright? So what are our inverse function values? If I have x equals 3, what do I get for my inverse? Good, just whatever the x value was in the original. So we're just swapping x and y. If I let x equal 9, I get 1. If I let x equal 243, I get 2. All right, can you graph those, David? Again, good luck with 243. You're not going to be able to do it, but
2, 3, inverse. The domain range.
once he does it, yep.
Okay.
And now you need to get really big for x, and where's your y going to end up? Well, how big is x going to be?
Yeah, that's even 243.
So where's that going to be? If that's 5, then 10, 15, 20, 25, 30, 30. Yeah, it's going to be like 3 rooms down to the right, which is outside in our neighbor's yard. But where's the y value going to be? So how are you going to draw that? It's got to go up very slowly now, doesn't it? So it's not going to be quite up to 2, nowhere near up to 2 actually, right? Because it's going up very slowly. So go ahead and draw and keep going, and it's going up very slowly. So even at x equals like 50, you're probably at like 1.3 or something like that, right? All right, so can you erase, Brogan, your left red line down to where x equals 0? And do you see how his bottom black line is the inverse of the top red line? Is that clear? All right, so what do we got? We got domain on his red line is from 0 to infinity. Hold on. There it is. So for the inverse one, came and used black ink because his inverse is black. So the red one up at the top, domain from 0 to infinity, range from 3 to infinity. Now he's going to do Brogan's inverse. And Brogan's inverse has a domain of
It's 3
to infinity. And a range of
all numbers. Or
so the y values for Brogan's black line can be anything. Is that what you're saying? The y values for Brogan's black line can be anything. What can his y values be? His line goes off toward the door and keeps climbing. Will it climb forever?
yes.
So his range goes to positive infinity, but where does his range start? What is the y value of where it starts?
Starts at um, 3 is for x.
And what's the y value there?
0. So it's 0.
Very good. So there's no y value less than 0. Rebecca, how do we know that? I mean, maybe the graph turns down somewhere along the way.
It's random.
Right. So you're seeing a pattern here, right? And if your original function, you're going to keep getting your x bigger, is it ever going to do something weird, or is it just going to keep climbing? It's going to keep climbing. So this is a function where you don't have to worry about it turning. When you get to pre-cal, you'll do functions that turn all over the place. And you're gonna figure out where they turn and all that kind of stuff, okay? All right, now, came in the domain in red and the inverse function's domain in black, and the range in red and the inverse function's range in black. What do you notice about them?
They're opposite, just like the last one.
Okay, so it held true. All right, we need one more. So, Brilliant, you gotta come this way without hitting the table this time. Miss Adams, we'll let you do the third and final one. We'll give her a nice and easy one.
What color do you want?
Is this thing just getting loose in the? Let's slide it over. Maybe keep it from there. Support it a little better. All right. What did you ask?
Should I do blue or red?
Why don't you do blue? Actually, why don't you do red and black? Blue. Wait a second. What did you do? Rick, you did blue then black.
Mm-hmm.
You did red then black. So let's do black. Start with black. You did red?
There's too much black.
Yeah, I know. But at least it'll be up at the top. So let's do black, and then you can pick either red or blue. We should have had Brogan do something other than black as his inverse. All right. So let's do a nice easy one for her. Let's do a straight line. Miss Lindsay, how do I write an equation for a straight line?
Either x or y equals 0.
Okay. So if I do x equals 0, what does that line look like?
No, x equals 0.
Yes.
Outward.
Going through. It goes through the point x equals 0.
Yeah.
So everywhere along that line, x equals 0. What do we call the line where x equals 0 everywhere along it, Amanda?
The y-axis.
It's called the y-axis. So what if I want a line that's not vertical or horizontal, Hannah, but I want like a diagonal line?
It'd be like x equals 2.
That would be another vertical line, except that now it will go through the point x equals 2. Everywhere along that line, x equals 2. I don't want a vertical line. I want a slanted. No, I don't want a horizontal line. That would be y equals something. I want a slanted line. What's the equation for a slanted line?
First degree.
It is a first degree equation.
X plus 2.
That'll work. How about if we multiply something in front of the x?
4x
4x plus 2. And Mr. Bond, what's the standard form of a first degree equation? It's ax plus b equals, you could say y, you could say, I think the standard form is ax plus b equals c or something, but whatever, yeah. But we have a special form of a first degree equation called the slope-intercept form. What is that?
Y equals mx plus b.
Did it ring any bells? Y equals mx plus b. You're going to need to know this for your final, right? All right. So y equals mx plus b. And you see, there it is in green, but you're going to figure it out for us. Let's put in some values for x. Yeah, whatever you want. 0 gives us, okay, let's do x equals a half. You're fine. You can leave the 1. And then, they don't have to be in order. And then let's do x equals 1, let's do x equals minus 2, and that'll be enough. How many points, go ahead, Leah, you work while we talk. Henry, how many points do we need to draw a straight line? 2. Yeah, we just need 2. Rebecca, how many should we probably do just to make sure we're right?
3.
Probably should do 3, right? Just to make sure. Brogan, you're checking Leah, she's doing it right? Very good, so go ahead and graph those points, Leah. Good. Can you draw a straight line? It's hard to do. You've got enough points that you might be able to do it. You guys guys are more sympathetic to your teachers when you go trying to do it. Yeah, look, see? See? You guys laugh at your teachers, but it's hard. Alright, now does that go on? Does that go on forever?
Yes.
Okay, so how do we indicate that? It goes on forever at both ends? Alright. Miss Adams, is that a function?
Yes.
Is it a one-to-one function? So let's invert it. So pick a color, red or blue, and let's make a new chart that inverts it. Can you squeeze it into the right of yours up there?
Yes.
Miss Claxton, can you go up and do what the boys did? Maybe like circle the two that belong together or something so we don't get confused.
Go ahead, sure.
Yeah, go ahead and like circle Henry's two. Big circle around his two, and then make something around Cayman's two. So go ahead, Dan, invert it. Good. And then graph it, man.
Can I erase this?
Yes. We're going to give her another chance to draw a straight line. This time she's got practice. Here she goes, she's eyeing it up. She's got a plan in mind. Oh, look, she's using her left hand for leverage. She's like, I got this. I got this. I'm all over this. Much better, much better. All right, is that going forever in both directions? All right, let's see how she did with her first line. Oh, look at that. Other than hers is not as straight as the other one, it's pretty good. All right, so Rebecca, what's the domain of her black line?
All real numbers.
And what's the domain of her blue line? So, that's an easy one, isn't it? If you swap the domain and range, it stays the same because they both go all real numbers, okay? Now, I guess Leah's up there with Large today. Leah, and you gotta see Rebecca, thank you. So, Leah, can you see, let's make her really work hard. Leah, what was the equation for your black line?
4x plus 2.
So can you write over maybe underneath that on the left there, can you write f of x equals 4x plus 2? That was your original one, wasn't it? Now, what card did you use? You used black for your inverse. So can you show me how to write the equation for your black line? How do we figure out the equation for your black line? Okay, now we actually technically needed to do a step before that. So I'm not sure whether to make you change it. I think I need to just not confuse everyone. So go ahead and take the eraser. Yeah, don't use your nice sweater. You take the eraser, and what do we write instead of f of x? We write y. So that's still the original equation. Now invert it. Now what do? Now we solve for y. And then what do we have to do in place of y? You can just erase the y. What do we write instead of y? We write
Inverse
the
function.
inverse function of x. You see how that works? You guys did that for homework last night, right? So let's see if she's right. You ready? Here's her original equation, and now we're going to write a new equation. It's going to be, I don't know if they'll let me do it her way, but if not, we'll distribute it and figure it out. Divided by 4. Look at that. Good job. So she just found me the equation of the inverse function of her original. Okay, do you see that? All right. Now, Leah, we're going to make you work. Can you do the same thing for the first equation up there?
For the x squared minus 1.
Yeah. I'm just going to bang that it won't take long. We actually did it before, didn't we? Rebecca erased it. Wonderful. So Rebecca, can you go back up to the board and you can do Broken.
Plus and minus.
Can you do the second equation? 3 to the power of x squared plus 1. Awesome. So I'm going to write that in. Can I reorder these, do you think? If I like drag it up? Oh yeah, we can do that. All right, so I'm going to write her new function, which is, I don't think it's going to let me do plus or minus, will it? I don't think it will. So we'll do x plus 1. Now, Henry, how do I write the square root of x plus 1 if it doesn't have square roots?
You square whatever it's equal
Say it again?
to. You square whatever it's equal
Well, I could. That would be reversing it. I just want to write what she's got, square root of the quantity x plus 1. But this thing doesn't let me put a square root symbol in. So how can I write it instead of saying the square root of x plus 1?
You write to the exponent of a half.
Very good. Everybody see that? All right, now it's getting confusing, but you see this purple line right here? That's the one that's tracking whoever's blue line that was. You see that? Now, I only have the positive here. Let me see if I put the negative in. You see what it did? Now, is that a function if I do both of them?
No.
If I do both the positive and the negative, you see what's happening? It's not a function, is it?
It fails the vertical.
Because it fails the vertical line test. So we restricted the domain, right, of the original one and said we're only going to let x be positive. And when we did that, then when we did the inverse, what did we end up with? We ended up with just the purple line that we have right there. All right, Rebecca, how you doing over there?
Great.
All right, so she let
You can do this.
f of x equal y, and she got y equals 3 to the power of x squared plus 1. Y'all see that? Step aside a little bit. And then she said, I'm going to reverse the x's and y's. And so she got x equals 3 to the y squared plus 1. And now she's trying to do something. What are you trying to do over there?
It's like taking square root, but you take it with that. whole
Okay, so
equation.
she's taking the y squared plus 1th
But then you
root.
can't
of
go
both
any further than
sides.
that.
And how's that working for you?
Can't. At least with what I know.
Good.
Get the y on one
Good,
side.
that's why I
by
said
side.
shift there. Good job. All right, so which one is that one? That's this third one here, right? So let's put a new one in right underneath this third one. And we don't know what that's going to look like, except that, hold on a second, which one is the inverse, which one is this one? Let's put it up there. It's the blue one. All right, so it's this red one. Who did that? Brogan. And then Brogan, what color you did? It's this black one, right? So Leah, you see this black one that I'm tracing?
Yes.
Don't erase that, but erase everything else, not the charts or equations, just the lines, but don't erase this one. There's a little bit of black on that orange line if you can get to that. Perfect. All right. So, I wonder if I could put this in absolute value or something. I don't know. Let's try this. X greater than or equal to 0. You gonna let me? I don't understand this. Do you understand that? No. So I don't know how to put in domains for this thing. Can I put like an if statement in there? don't try defining I or F. I don't understand.
What if you wanted to like settings instead of
All right, so we're just gonna leave it like that. Go ahead, Hannah, what'd you say?
domain? What if you went into like settings instead of domain? Because before you were able to change your
Scale size.
yeah, change your scale size.
Yeah. I think I can, there's a way here to do it. I'll have to learn. All right, so we're just gonna take, not including this left part here. I don't know how to force it to do that because it doesn't understand me. So, but just this right side is what, is what Brogan had before, right there. Okay, and there's his inverse. All right. So so how do we do? So here's Leah's line and her inverse, right? Here's Brogan's line and his inverse, this one here. And then whose was this? Purple.
This was,
Uh,
That was,
That's this one? No, what is that?
it was,
probably
it's the inverse of this
Uh,
one. Right.
This is the inverse of that one. All right, so hold on. So
You just don't have
where's? Oh, I don't have this one shown. That's the problem. That's the problem.
here we go.
And again, we want to restrict the domain to not be the left side of these parabolas. All right, so here's the parabola, and then that purple one is the inverse of it. Will you give me 2 minutes to figure out how to restrict the restrict it? Let's look up Desmos. There's got to be like an instruction manual on this thing, right? So help, getting started, user guide. Variables, so let's see if we can search for domain. Domain and range restrictions, add the restriction at the end of the equation. So you just say x, what? Example, add the restriction. Oh, there it is. It's in, see it here? It's in, what do you call those, braces. All right, so let's go back and add our restrictions here. So which ones do we need to do? We need to do this red one, and we're going to put in braces, and we're going to say x greater than or equal to 0. Did it work?
Mm-hmm.
Yes. All right, and then what's the next one we have to restrict?
No, you need to put a, you need to put a brace on the red one.
What's that one?
You need to put a brace, or take off the parentheses on the red one.
On the red one.
It went
Okay.
away on the warning sign.
Oh, what did it not like?
No one can see it because it's.
you added the parentheses,
That.
Yeah.
Is that right? Oh, this.
the parentheses.
Like that.
Yes, sir.
All right, thank you. And then the blue one was the other one? We want x greater than or equal to 0, like that. All right, I think we got it. Why are they showing me these points?
So they're on both lines.
Is that, oh, it's showing the
I
intersections?
think so.
I don't know how to turn that off, but we can live with that. All right, so there you go. We've got 6 things. The only one we don't have an equation for is the one that Rebecca couldn't find an equation for. So we'll just leave that one as Brogan's handwritten graph here. Okay?
Can
Now-
you find the equation for that?
Say again.
Can you find the equation for that one?
Can I?
Is it possible?
Yes. Yes. And you will be able to do it by next week. Okay?
No.
That's what you'll be learning in this chapter. Now, does anybody notice anything? So let's take this this blue one right here, and the inverse is the purple. No, that's wrong. That's wrong. Let's take the purple one. The inverse is this red or orange one. Everybody see that? Now, can you see that if I move my pointer back and forth, that these are kind of mirror images, the points are mirroring, and then they're crossing right there, and then these are all mirror images of each other. You see that? Now, Brogan, yours is the blue one here, and then the black one here. I'm going to take my pointer, and can you see that these points where they start are mirror images of them? That would be about halfway right there, maybe about there. Is about halfway, and then if I keep going back and forth, can you see that I'm just mirroring it? You see that? I'm mirroring them, and then Leah, you've got these lines. And can you see that those are mirror images of each other as well? You see that? In other words, each of these functions and inverses are mirror images of each other. So is it possible to find a line of symmetry for each of these pairs such that you could fold it in half and it would be an exact match?
Yes.
All right. So Leah, can you do that for maybe why don't you switch places with Amanda? Amanda, can you do that for the Rebecca? You can obviously. Amanda, can you do it for the purple and this reddish orange one? What color is it?
It's red.
Is it red?
It's
So
red.
purple and red. Amanda, can you do a dotted line that's going to show us the line of symmetry around which we could fold those two curved lines and have them match up perfectly?
This is kind of a straight line.
Does everybody agree with that? That that's the line around which the purple and red would fold to perfectly line up? Looks good to me. Leah, your green and what color is that? Orange. Your green and orange lines, where would they fold around? What line of symmetry would they fold around from the looks of it? Can you use Amanda's line?
Yes.
It kind of looks like that, doesn't it? We can use Amanda's line for those. How about, Brogan, your blue and black lines? It's weird, but can you fold it around Amanda's line? Huh. You think that's true for every function and its inverse? Not that exact line. You might be right. So can you erase all those equations on the left there, Amanda?
Over here.
Yeah. And let's turn these off. And let's drag these up. I'm gonna get two of them here. And let's do like a parabola that is shifted left. Mr. Acton, how do I shift a parabola? And let's have it open down and be wider than our normal parabola. Can you give me a parabola that'll do all those things?
Yeah, that would be negative one quantity x.
Let's shift it left, say, 4 places.
Plus 4. And then what else did you want?
I want it to open down and be wider than a normal parabola.
That would just be minus, no, less than half.
Okay, but if it's opening down, it has to be
Has to be negative.
negative. So let's do negative a half. Now, what do I have to do to make it a parabola?
You have to, hold on.
We have to square it. Now it's a parabola. Now, can we shift it up 2 places?
Yes.
How?
You would just minus 2
That would shift it down 2 places.
plus.
We'll just add 2, and every x value now gets 2 added to it, so it shifts it up by 2. Well done. But we want to restrict the domain, Henry, so we're going to say we only want x to be, actually, you tell me, how can I turn that into a true function, Henry? Is it a one-to-one function? It is a true function right now. How can I turn it into a one-to-one function?
You would do x is greater than or equal to negative 4.
Very good. Everybody see that? Very good. We got that? Now it's a true function. Yeah. All right. Amanda, can you find the equation of the inverse of that thing? So here's the original function right there. So on the left board, move over. We got 4.5 minutes, so don't hurry. Negative 1/2 quantity x plus 4 squared. Go ahead and use 1/2 instead of 0.5. Negative 1/2 quantity x plus 4 squared.
Can I change it to y?
Sure. So you're just going to go ahead and jump to that. That's fine. See what she did, everybody? Okay, that's it. Oh, plus 2, yeah, that's good. All right, we're gonna solve for y, so we're gonna subtract 2. And then we're gonna multiply by -2, and we're gonna have y plus 4 squared. Okay, let's multiply that out.
-2x plus 4.
Good, equals, yeah, we're gonna take the square root of that. And if we introduce the square root, thank you, and then we're gonna subtract 4 after we took the square root. She's just cutting out some steps along the way. And if we restricted the domain on our original equation came in, we restricted it to -4 and greater, okay? Then that domain becomes the range of our inverse. What was the range of this original? The range was y values started at, y values started at,
Positive 3, positive
2 and went to
2, negative
negative infinity. So we would say, we always do it in number line order, we would say the range is from negative infinity to positive 2. So if that's the range of the original, is that the domain of our new one?
Yeah.
All right, so let's try that. We're going to make our new range to be x less than or equal to positive 2. And what's your equation there?
Square root of -2x plus 4, and then out of the square root.
All right, so we're going to do -2x plus 4 raised to the power of 1/2, and then the whole thing minus 4. There we go. There's our inverse, and does that mirror around the same line, Mr. Tripp? Yes, sir. So have I convinced you yet that every function and its inverse will mirror around that same line?
Well, what if they were, I mean, what if the two functions were kind of opening toward quadrant 2?
Go draw one. We only got a minute and a half left. Draw what you mean.
Well, instead of, say, having these kind of go like this, I don't know, but what if this thing was up here?
Go ahead. Just see if you can draw something.
Are you saying like flip them over? Like flip the parabolas over?
So hang on, let me just get this for a minute. I'm not controlling it in my head.
So is that. That's why I asked you to draw. So while he's thinking about that, your homework then is just to finish 10.1. Okay? Finish 10.1. Yeah. Finish 10.1. Why don't you actually do 10.2 up through example 3, which is to say problems 1 through 1 through 14. Okay, and it's just looking at an exponential equation. You're not doing anything with the j except kind of graphing it.
So that standard equation that goes through 0, that is like y equals x plus 1.
If it were x plus 1, it would not go through 0, 0. It would be up 1.
Okay, so that standard line symmetry is y equals x.
It's half.
So I was just saying, if we made an x